You're watching the 9.1 lesson video on graphical displays of univariate data. And univariate, it looks like a big fancy word. It's not. It really just means one variable data. All right, so let's talk about what is going on here. We're starting statistics. It's very different from many of the other units that we've talked about in the past, and most importantly this year. We really haven't done anything with statistics. So the first thing that I just want to point out is vocabulary is huge this unit. And also being able to use your calculator and practicing on the calculator is huge. Typically, you can't make it through a lot of the questions if you are not using your technology. So whenever you're watching these lesson videos, it's very important for you to make sure that you have a calculator in front of you. Watching me do it is totally different than you doing it yourself. First vocab word, quantitative data. Basically talks about quantities, so numbers. Okay, if you look at exercise number 1, this is a really good example of quantitative data. There's a bunch of ages, and they're categorized in what we call a dot plot. And this is Charlie's Food Factory, and they're telling us that 28 workers, whose ages are shown below, are actually portrayed on this dot plot. So what we're going to do is use this dot plot to answer the questions. Part A, how many of the workers are 18? So what we're going to do is we're going to find where 18 is located on our dot plot, which happens to be right here. And how many dots do you see? 1, 2, 3, 4. So how many of the workers are 18 years old? 4. And it says, what is the range of the ages of the workers? Well, the range is when we take the highest value, which is 42, and subtract away the lowest value, or the youngest workers. And once we subtract, we end up getting 26. Part C asks us, would you consider this distribution, so all of these point values, symmetric? And we think symmetric, well, we're looking at the word symmetry, so think a butterfly. We want the data to be the same on both sides. Unfortunately, that is not the case here. You can see that our data towards the left side, like the 15 through 25 range, it's very concentrated down there. And we don't see much going on the right-hand side. But there are data points. So we call this, well, we would say no, not symmetric. And we can call this skewed right, because the tail happens on the right-hand side. Part D says that the mean, and this is something we'll talk about in a few more days or a few more lesson videos. You might even remember that the mean is the average. So it says the mean age for the workers is 22 years old. So they calculated it for us. What they really did was they added up all the values and divided by the total of 28 workers. Now, 22 happens, you know, right here. And really, does that look like the average of all of the data? And I would say no, that's not really a good representation of this data. So what happened? Why is it higher, than what we would have expected? And we are going to attribute that to all of these points that you see on the end. The 30, the 35, the 38, and the 42. We call those outliers. So why is this average not representative of a typical worker? Because there are outliers in the data. And we'll talk more about, different types of measures that we can use to represent the data. Maybe the mean would not be the best example. Okay, exercise 2. So a farm is studying the weight of baby chickens after 1 week of growth. They find the weight in ounces of 20 chicks and show the weights below. What you're required to do is create a dot plot. All right, this is not bad. This is actually very, very easy. All you're going to do is put a dot anytime you see the weight of a baby chick. And you're going to do this for the entire diagram. I'm just going to do the first few with you, so 3 and 4. And then anytime you have a repeat like a 2, you're just going to stack it. So finish doing that. Okay, when you're done, this is what it should look like. If you want to double check, just go ahead and count and make sure that you have a total of 20 dots, which would represent the 20 chicks. Moving on to exercise 3, here's another vocabulary word. The following histogram shows the ages of the workers at Charlie's Food Factory, but they're using a different format to describe this data. So we're using a histogram instead of the dot plot. Okay, this might be a little bit nicer to see. The first thing that you might notice is that the ages are now in ranges. So it's not like just a 16-year-old, just a 17-year-old. They're categorized into different groups. So in part A, it says how many workers have ages between 19 and 21, and all we have to do is look at the top of that bar of the histogram to realize that there are 11 people who have ages between 19 and 21. Now B says, what is the disadvantage of a histogram compared to a dot plot? So the thing that I notice with this is that histograms don't show, so they don't show individual data points. And they show us, well, we call them intervals. So intervals instead. And then C says, does a histogram have any advantages over the dot plot? And I would say yes, because I think it's a lot easier to read the data. It's easier to view, so it's nicely shown in bars. So easier to read. All right, moving on to exercise number 4. It says the 2006-2007 Arlington High School varsity boys basketball team has an excellent season, compiling a record of 15-5. So 15 wins, 5 losses. The total points scored by the team for each of the 20 games are listed in the order in which the games were played. Well, when they give us this data, what we have to do is organize this data. And we can definitely do that. What we're going to do is tally. So we're going to find, and I'm going to pause the video and let you kind of do this on your own. But a 76, where's a 76 going to go? Well, that's going to go in the 70 to 79 range. So take a minute, pause the video, and start tallying up all those values. So here's everything tallied. The frequency is just counting up all the tallies. So I had 3 tallies, 8, 6, 2, 0, and 1. The next thing that we need to do is construct the histogram below. What we're going to do is create and replicate something that you see right above here. So we want to make sure that we give it a title, that we label the axes, and that we're showing the intervals and making sure that the intervals are touching one another. So what I always typically label my y-axis is the frequency, and then down below here, this would be the points Actually, I think I need to give myself a little bit more space to write in those intervals. So points scored. And what is happening here? Let's just say basketball team. They didn't give us much space. I'll squeeze it in up here. Maybe we should say what the Arlington, or the high school Arlington. We could also say boys, whatever. Okay, so frequency. Well, our frequency has to go all the way up to 8. So I think that we can start off at 0 and maybe just count each one of the blocks as 1. I'm just going to label everything with even numbers so I don't have to label it all. But as you can see, I'm still counting every box as 1. The next thing that I need to do is 1, 2, 3, 4, 5, 6. I need to put down 6 different blocks of my histogram. And I think I can make them 2 wide. So this would be my 40 to 49 point range. This would be my 50 to 59, and so on and so forth. All right, so once you have all of those labeled, what we're going to do now is actually create the boxes in the histogram. So my first category, and this is where using a straight edge comes in handy. I actually don't have one, but I'm just going to show some shading just so it's easier to see. Here we went up to 8, and then we'd use our straight edge to help us with these sides. Then we go up to 6. Then we're down to 2. Next is 0, and lastly 1. Now, sometimes you'll see people shade. You definitely do not have to do this, as long as it's easy enough to see. But if you're using a light colored pencil, I think that shading sometimes just helps the reader to see, especially if you have dark lines on your graph. What I also see sometimes people do is write out the actual frequencies on the top. This is definitely something that would go above and beyond. You could put a 0 in there if you wanted to, but this is just making sure that you're being thorough with your frequency histogram.